Hey guys, what's up? QNX. Today I was trying to instrument an executable in QNX that is going to execute into a QNX remote target to compute execution coverage metrics from that remote target. Open source tools can only give you statement coverage, but I wanted time1.c structural types of coverage, which is statement, decision, and MCDC. The tool that can give me that, and which is the tool that I'm using today, is Parasoft C++ test. But first, let us try to understand how this works. I needed a CMake-based project, but I was surprised to learn that the Momentex, the IDE that is used to build QNX project, Momentex IDE does not support CMake-based build system. So I went to their website here, but I only saw this snippets of code, sample programs. Their Momentex IDE can only generate makefile based project. And I learned also, to my surprise, that the recursive make that Momentex uses is considered harmful. So as you can see, I needed to have a CMake project here. But first, I have to understand the provided example code. time1.c looks like a server that enters into a loop and receives messages from a client. But none of these other examples here is that client. Anyhow, I downloaded time1.c here, and I compiled it and run it into my QNX target. I also set up a CMake build script of the project, and I run it into my QNX here, and I saw the messages of the server. But I needed a client in order to have a complete example. So I traced that it uses a PID and a channel to communicate. So I created another executable. I named as another.c, another process that will talk to this server here, since the example do not provide a corresponding client. And then I extracted the common communication header to protocol.h, which is included both in the client and in the server. So first, let us build this project using CMake and run it into our QNX target so that we understand how this client server behaves, because we are going to instrument this later on using Parasoft. So we have a start setup here. So I'll run CMake. It created the build folder, prepare the necessary Ninja script, and then I will have to run Ninja to build the two targets. So now I have the client and the server. I will copy this client and server into our QNX target, and then let me switch to our QNX target. These three split terminals are all the same terminal of the target. I just split them into three. So we have it here. They are not yet executable. Let's try to change the permission. And now they are executable. So as I've said, as you read through this documentation here, it will teach you the basics of inter-process communication of a QNX system. So let's have it test run here. I will run the server. And now it is got a pause waiting for a client to talk to it. But I've learned that in order to talk to that, I needed the PID of this server, time1, and that PID is here. So I will go to another terminal of the QNX and run another, supply it with a PID and the channel which is 1 by default. And I will have to press wait. Without pressing enter yet here, I will go to another terminal and type the same PID in the channel. And this time I will send the value message 1, 2, 3, 4, 5. So the way that this example works after all, because this one is the message broker, centralized message router. So the two clients, this one and this one, are going to talk to each other via the centralized message broker here. So I will run the first line, wait, and I will run the second. You can see the message sent by this client has been received by the other client. All of that routed to the centralized server here. Okay, let me kill the server now. So that is how the flow operation. All right. So this one, after all, is just a pub sub mechanism. Let's go back to the project, and I need to instrument to run again and to instrument it. I will build. I will remove the build folder. Okay. Very important to remove the build folder to remove the .o object artifacts and whatever was compiled previously. We need to start scratch, because if you will not remove the build folder, stale.o files, if you have a very big project, will remain, and the Parasoft instrumentation is going to miss to include that necessary object file. So now that I remove the build folder, I'll run again the CMake. And now I will show you the Parasoft utility tool called CPP test trace, which is in this location. The CPP test trace is used to daisy chain into the build so that it will know who are the C and C++ source files that are part of a particular build. Now, we saw that when we build everything here, this command here builds the two, but I'm going only to instrument the server side. So I'm going to build time1. But then I'll have to prefix this with a Parasoft utility command. Okay. So this command here will build time1. This will just give you a normal build. All right. This is not the instrumented build yet. This is just the normal build. By prefixing it with CPP test trace, the intention is to generate a BDF text file which Parasoft needs to collect who are the C and C++ files, the compiler options needed to build this binary. I'll press enter. Now we have this time1, and then we had generated the BDF text file. Let us take a look at the BDF. So all of these informations, like the argument, O3, QNX options, it will be used by Parasoft to do the final instrumented build. All right. So with this generated BDF, I'm going to load this BDF using the Parasoft standalone IDE. Take note, standalone IDE. This is the IDE that is bundled by a Parasoft called CPP test. So I have another terminal here, this one, and that this is a standalone IDE. You can also click this as an icon on your desktop. But I will run the standalone IDE in this terminal, because this terminal here has the environment variable set to access the QCC QNX compiler. If you already have QCC globally set in your Windows environment, then you can run the CPP test by clicking an icon, and it can find the QCC. But since I set the QCC by sourcing it, what I mean is by sourcing this, okay, it's already sourced. What I mean is by sourcing this file here, you source this, okay, like source QNX like that. After you source that, for example, before you source that, you cannot see QCC, but after you source it, and now you can see QCC. So that is how it's done. So here, I have to launch the Parasoft CPP test IDE here, okay? So that it can inherit the path of the QCC compiler. And I need to create an associated workspace here. This is an empty workspace. Let me enable high verbosity. Right. So this is the empty workspace. I will load the IDE. I'm in the BDF. I'm here using create a project from a build data file. And that is BDF is here. The compiler family is not automatically set by default. You need to set this to the closest matching compiler family. Mine is QNX 8. That is the best I can have here, QNX 8. A mismatch in the compiler family will result to failure to instrument, failure to static analysis, because the compiler family contains the ADG settings, nuances of a particular version. Yes, and you can see that QCC, Q++ has been set. And you can see now why I needed to launch the CPP test, because I did not set a full path of this executable here, because this is reachable from a terminal and the IDE is launched from a terminal. It inherits the path of QCC. Right. So this is the time1.c. We need to instrument. Of course, from here, since we loaded it, we can run select time1.c and run static analysis first if you want. This is first proof that you have set up things correctly by using static analysis, and maybe select recommended rules. So working static analysis is a good indication that at least you set up correctly. Now we have one violation. Oh, that's it. So okay, let's delete this violation. But as I told you, we're interested in code coverage. So what we're going to do here is that in the Parasoft test configuration, there is a QNX template here. Build and run application with memory monitoring. We're going to duplicate this. And now it's in the user defined. In the duplicated version, we can change it. The target is now set to mine is QNX target. And let me check the home. This is the home. There. And QNX user. So I set this thing into my SSH. Let me explain that you will not be confused. See, in my SSH config here, I set the QNX target to have this 2222 because my Vim my Chemo QNX remote target is port forwarded to port 2222, and I'm using this identity file for a passwordless SSH access, and I needed to specify the message authentication code to this value because I saw that the QNX SSH server have limited message authentication code format supported, so I need to supply the correct client to match. If you do not specify in the config and instead use the correct IP here, when you run the unit testing, it will prompt for a dialog asking for a password. Okay, it will sometimes the dialog will be hiding in the corner, and that's why I avoided that flow. I needed to have a password list, but you can try it. You can try it, and it will pop a dialog so that you can type for a password. That's okay. So I will apply this. Right. So let's begin. So I will. Okay, but before I begin, let me show you what's configured here. Okay. Here, okay, this is the duplicated rule, and I will enable statement, decision, and the MCDC. Very unique coverage, only available in Parasoft C++ test, because there is no open source that can give you this type of structural coverage. And now let's go to the XML. Let me explain what's happening here, and this is something that you have already been doing, you're just not aware of it. Like, first you cross-compile everything, and then the cross-compiled firmware you copy it, okay, using SCP, and then use chmod here. You remember we do the chmod ourselves. Now it's being part of an automated process, chmod, and then we run it. After running it, it will generate two files: the clug and the tlog and the clig. It will be copied back to our laptop, and this is what is being used to generate code coverage. In your open source versions, this is something like GCDA and GCOV. Now that we have, and then we clean up, okay, clean up the remote, remove that artifact. So now that you saw how that flows, let us run that flow. Okay. So okay, let me run the flow. For example, let me make sure. Okay. We still have the old time one here, but this will be overwritten by the new one when we run it. In fact, I can remove this time one here, but we will keep the another process here. Okay. So I will run now this from the IDE. Right click, Parasoft. Test using user-defined embedded systems, QNX, and this is our customized this configuration, which we enable statement, decision, and MCDC coverage. And you saw in the XML from top to bottom the SSH and the SCP command of how the test works. So I will click this menu and go to the console tab. And it is running inside the QNX target. See? And I need to go to the QNX system. And this is the test exec. This is the instrumented. And I will copy the speed. I still have the the client here. Okay, I'll run the client. I'll specify the feed, the channel, and then I will send 1, 2, 3, 4, 5. Okay, okay, it's still running, but inside the server actually is a special code wherein if I send 42, it will stop the loop. Okay, then as you can see, code coverage have been generated, and in fact here it's no longer running, and we have code coverage here. So we can go here and go to the execution. Okay, let's generate a report. Hmm. Me, okay, I only enabled line coverage. I will enable decision MCDC. I did not save the last. Sorry about that. Apply and close. Okay, so let me delete this. Let's rerun again. All right. So to click this and then Parasoft history. So it's running again in the remote. I'll need to get the PID. Let me exercise some calls. So instead of 42, which will exit, I will start 44. Okay, and then I'll have it exit. There, it's computing the coverage. And then I'll generate a report. As you can see, we have line, decision, MCDC. Perfect. Go to report. Every column. Okay. Line coverage, decision coverage, MCDC. That is all.